Okay, in this video, I'm going to work numbers 11 and 16. And the reason why I'm going to do those two kind of out of order is because they're both derivatives of inverse trig functions. And when you look at this one, the answer choices really give you a lot of help here because you may have completely forgotten about an inverse trig function. And then you look down there and you see arctangent, and so you think, oh yeah, arctangent, that's the same thing as tangent inverse. And so this could be an inverse trig function. And the natural logs don't work because, this is to the second power. Remember, when you use a natural log, it needs to be to the first power on bottom. And so, A and B are out of the question. We're going to use arctangent in order to take the derivative of the antiderivative of this. But it is helpful to know the derivative of tangent inverse if we're going to take the antiderivative. So the derivative of tangent inverse of u, hopefully you remember, is 1 over 1 plus u squared, and then times, u prime, whatever the derivative of u was. If u were some function on the inside, we would just use the chain rule and multiply by its derivative on the outside, right? So the main idea here that you can see from this derivative is that you have a 1 and you have u squared. Well, when you look at the 16x squared, and you think to yourself, all right, now what could I square in order to get 16x squared? Because whatever is right here needs to be equal to u squared. So 16x squared needs to equal u squared. Well, if you take the square root of both sides, you would get 4x is equal to u. And so that would make things really easy if it weren't for the fact that there's a 4 right there, because we need a 1 to be in that first spot, not a 4. And so what I'm going to do is I'm going to try to turn this front spot right here into a 1 rather than a 4. And so there are several things you can do to turn a 4 into a 1. You could subtract 3, but the thing that I'm going to do, and let me go ahead and just multiply by this dx on the outside and call this 1 over 4 plus 16x squared dx, and just move it off to the side. Now the thing that I'm going to do to change this 4 into a 1 is divide by 4. 4 divided by 4 is 1, but this is not a legal algebraic move if I just divide that one thing by 4, right? I'd be crazy. So what I have to do is, if I'm going to divide that by 4, I have to divide everything by 4. And so when I start dividing everything by 4, this thing on top has just been multiplied, so it's a 1/4. I'm going to bring it out and just leave a 1 up top. And so you can see I could multiply 1/4, times the top of this fraction, and that would make my 1/4. So what I've done is perfectly okay. All right, and then on bottom, 4 divided by 4 makes 1, plus 16 divided by 4 is 4 with the x squared. We're trying to take the derivative with x. And now I'm going to use my u substitution. Now remember what I said earlier, this, whatever is in this position right here, has got to be equivalent to u squared. Okay, because this, the derivative of an inverse tangent says that this position is where u squared goes. So if I took the square root of both sides now, I would get that u is equal to 2x. So that means du dx, my derivative of u with respect to x is going to be 2. And if I simplified, I would get that dx is du over 2. So I'm going to use that u substitution now. This is 1/4 times the integral of 1 over 1 plus, and remember, I'm going to substitute in for u, but this is not u, this is u squared, right? Because u is 2x, so this is u squared, which is what I want, because that is how you actually take the derivative of inverse tangent. You get u squared in this bottom position times du over 2. Well, this du over 2, that 2's on bottom, so I can multiply it out front by the constant, so this is 1/8 1 over 1 plus u squared du. And now this is exactly the derivative of tangent inverse. So this is 1 over 8 times tangent inverse of u plus my constant of integration. And remember, we said that u was 2x. So I'm just going to plug that in now. So we get 1/8 tangent inverse of 2x plus my constant. And so that looks like answer choice C. Okay, now let's move to number 16. Number 16 says 1 over the square root of 4 minus 9x squared. And so this is going to work just like number 11, except for the fact that we're using sine. Now remember, the derivative of sine inverse of u is 1 over the square root of 1 minus u squared times the derivative of u for the chain rule. So I have the exact same dilemma here. You know, I have a 4 instead of a 1 again. Okay, so I'm going to do the same thing I did last time. I'm going to take this integral of 1 over the square root of 4 minus 9x squared, and I'm going to divide the 4 by 4. And so I'm also going to divide the 9 by 4. Now there's one big difference here from the previous problem, and that is this. I'm dividing by a 4 on the inside of a square root. Okay, so these two 4s are on the inside of a square root. So the result is that what I'm in essence doing is dividing by 2. And this is why I say that, you know, if we have the square root of 4, and, you know, that, you remember the square root of 4 is equal to 2, right? Well, if I come in here and I divide by 4 on the inside of this square root, well, then now the result of this square root is 1. Well, how do I get that to match this 2 on the outside? Would be to divide by 2. So notice, you know, what I started with is 2 is equal to the square root of 4. And so if I divided by a 4 on the inside of the square root, in order to make this statement still true, I had to divide by a 2 on the outside, or the square root of 4, right? And so that's why whenever I've done the bottom, I've divided by 4 in both places, but they're inside the square root. And so on the top, I'm going to need to divide by a 2 with respect to x. So now what I have is 1/2. I'm just going to pull this 1/2 off the top and out front. So that's my 1/2 times the integral of 1 over the square root of 1 minus 9x squared over 4. Okay, and if we remember, this position right here in the derivative is a u squared. So u squared needs to be the same as that. So u squared should be 9x squared over 4. And if I take the square root of both sides, that'll give me that u should be 3x over 2. So if I did du dx with this u substitution, that would give me 3 over 2. And now I'm going to solve for dx just like normal, and so my cross multiplication will give me 2 du is equal to 3 dx. And now to get dx alone, I should divide by 3 on both sides. And so this is what I'm actually going to be subbing in, is that dx is equal to 2 du over 3. So let me get ready to do, you know, both of these substitutions. I'm going to substitute this for my dx and this for my u. So what that means is that we have 1/2 times the integral of 1 over the square root of 1 minus. And now, you know, if u is 3x over 2, then this stuff right here is u squared, which is exactly what I want because this is how the derivative of sine inverse looks. And then dx, I'm substituting in 2 du over 3. Remember, I got that from, you know, right down here. Right down here. That's where that substitution is coming from. Okay? And now I'm going to take this 2/3 as a constant and multiply by it out front. Okay? So that 2/3 as a constant, I'm going to multiply out front. So 2 times 1 on top gives me 2. 3 times 2 on bottom gives me 6. This is the integral of 1 over the square root of 1 minus u squared du. And now this looks exactly like sine inverse. So the fraction will reduce to 1/3, and then this is just sine inverse of u plus my constant of integration. So u was 3x over 2. I'm going to plug that in, and so we get 1/3 times the sine inverse of 3x over 2 plus c. And that looks like answer choice E, 1/3 times sine inverse or arc sine of 3x over 2 plus my constant of integration. Okay, that's all for this video. I'll work a couple other problems in the next one.